Welcome. My name is Alex, and this is Watch Repair Tutorials. I retired from watchmaking after 35 years, and today I love to share what I know with those who are excited about learning watch repair. This is lesson 4 of my basic series for amateur watchmakers just getting started. Today's lesson is all about what you need to do before you take out that first screw. All right, so I'm sure you're all raring to go. You've bought your starting tools, you've got your workbench set up, you've got your desired loop figured out, and you've got adequate lighting, and you've bought an ST3600. You are ready to start taking the movement apart, right? Well, not quite. A lot of people ask me, why not just grab a broken watch movement and try to fix it? Isn't that a great way to learn? Well, the short answer is no. No, it's not. You may learn something, but it's not going to be what you want to learn. If you are attending watchmaking school, the first movement that's given to you as a student is the ETA 6497. It's a large manual wind movement with 17 joules and a power reserve of 46 hours. We use the ST3600 with the small seconds at the 9 o'clock position because people learning at home don't want to shell out about $250 or more for an actual ETA version. Now, there are many Chinese companies that make their version of the ETA movements, but the best version is the one made by Seagull. Seagull has the highest standards among Chinese manufacturers, which is why their movements cost a little bit more than the other versions. I regularly can get an average rate in 5 positions at around 5 seconds a day. Now, I purchased the ST3600 directly from Seagull Hong Kong, and I have them on my website store if you're looking for one. The ones you see on eBay for about $35, those are not made by Seagull. When you begin learning on broken movements or even movements that run but need service, at this point in the game, you don't really know that much. You're not familiar with what a well running movement looks like. You haven't seen the balance running properly. You haven't seen what proper end shake looks like, or really how any of the groups of parts interact together when they're operating properly. You need to know what's correct before you'll be able to see what's incorrect. In order to fix a watch, you first have to learn how to service the movement. And the way you do that is by going through the entire process on a movement that you know is running well, by taking it apart, cleaning it, putting it back together, and lubricating it so that when you're done, it runs at least as well as before you took the first screw out. That way, you know that your processes are good enough for at least a short term rate stability. Now, what do I mean? Well, first, you have to be able to take a movement apart and put it back together without bending or breaking any pivots or messing up the hairspring. Secondly, you need to be able to wash the parts so that not only are they clean, but that they're chemical free, meaning that there is no residue left behind on the parts or the hairspring. Now, what does that mean? Well, a chemical residue will change the surface tension of the steel. And when you lubricate that part, the oil wants to creep away from where you put it and it wants to go where you don't want it. And just in case you're wondering if Epilam will solve that problem, the answer is no. The parts also have to be chemical free to apply Epilam. And lastly, you have to get your lubrication levels correct. There can't be too much or too little in your application. It's got to be just right. You also have to be able to clean your end stones and provide the right amount of clean oil to the balance pivots. If you've never taken a screw out of a watch movement before, you may not realize how small they really are. One thing that I highly recommend that you do prior to removing your first screw is to spend a little time and practice picking up screws and moving them around. Start with a pile of screws and just practice picking up a screw and moving it into a new pile. Do this as long as you need until you feel comfortable picking up screws with your tweezers. Next, pick up and turn the screw while holding it in your tweezers and practice it turning it over and back and forth. Notice how I'm holding the tweezers loosely in my hand. I have the tips of the tweezers adjusted so that they're very close together, and I'm applying just enough pressure to hold the part. Most people tend to hold the part with too much force, which can cause the part to go flying across the room. Remember, the goal when holding the part is to apply just enough pressure to be able to pick it up. If you lose the screw, you want it to fall down on the table and you don't want to launch it across the room. One of the biggest problems newcomers have is just losing parts. Losing screws, jewels, and springs may be the biggest problem that a newcomer has, and they create even a bigger problem. Yes, in some cases, you can buy these parts for the ETA version of your movement that you're working on, and they may be compatible, but it's not a guarantee. And none of these cloned movements have parts available to buy. When you buy one of these replacement screws from a supplier, they'll charge you $5 plus shipping just for one screw. So it's worth spending a little time practicing working on your skills. Here is a inexpensive eyeglass repair kit that has a whole pile of different size screws in it so that you can use these to practice on. So practice, practice, practice. Practice with parts that don't matter before you work on parts that do. The way we judge our work as watchmakers is very simple. It's how well the movement runs. This is the same thing the time grapher does, except the time grapher doesn't lie. It will tell you how good your service work really is. For some of you, you might not be in the position to get one at this point, but there are some phone apps available. The problem is that most of them don't give you amplitude. Well, I found this one that does, and it's an app called TimeGrapher X. Now, I'm not going to go into a long explanation of the operation of the apps. You can do that if you need it, but I wanted to see how accurate it was, so at least you know that. For the test, I'm going to set a baseline by using my eTimer software that I use on my laptop. This is a professional grade timing software that constantly calibrates itself with an atomic clock, so it is about as accurate as you can get for a timing machine. I'm just going to check one position to compare it with the other options that we're looking at. I'm going to use a brand new NH35, and I'm first going to test it on the e-timer. And here's the rate. And here's the rate with the time grapher X. Many of you are ready for a more traditional style machine, which means a clone of the Swiss timing machines. It's sold under many names, but I'm pretty sure that they're all made by the same company. The two available models are the 1000 and the 1900. The 1000 has a basic low resolution LCD screen compared to the 1900's higher resolution color screen. The 1000 measures all the standard beat rates, but the 1900 also allows you more beat rate variations. The 1900 has an upgraded mic stand, so you're probably getting a little better noise isolation. The 1900 also has faster processing, So if you're using the 1000, you need to give it at least a minute to settle in before you start taking a reading. The 1900 will settle in after about 30 seconds. And lastly, the software in the 1900 has higher sensitivity to the sounds in the escapement, so it is able to calculate the sounds it hears with a little bit more precision. So, which is better for you is really going to be determined by what you're going to be working on. If you're just going to be working on NH movements, for example, just get to 1000. Now, if you're going to be working on all different kinds of movements all over the place, the 1900 is probably going to be a better option. I did test the new time grapher with the NH35 that I used with the time grapher X, and here's the results of that. Now, I'm not going to go into a lot of detail here on everything that you can and can't do with the data from a time grapher. But before you take that first screw out, I want you to take the readings from your movement from 5 positions and write them down. The 5 positions are dial up and dial down, crown up and crown left. Now, when you're using a mic stand, the balance is typically facing up, right? That means what you might think is crown right is actually crown left and vice versa. This is because the dial positions are based on the way a watch is worn on your wrist, which is dial up. So when the movement is in the mic stand, it's actually upside down. It's important to remember this when running your positions because crown right is usually the worst position, but we're going to go into that in more detail when we get to the regulation part of this series. When taking your readings, start from a full wind and install the movement in the mic stand. You have to give the movement about 30 seconds to settle in when you're using the 1900 and a minute to settle in if you're using the 1000 model. Then allow it at least another 30 seconds and stop the time grapher. Write down the amplitude, the rate, and the beat error for each position and save this on a piece of paper for later. One of my goals for you in this series is for you to be able to assemble the movement from a pile of parts. Being able to identify screw types and where they go is part of that, and it will help you as you move to other movements. Really, there's only a handful of screw types that you need to know. Flathead screws can either be countersunk or they can sit on top of a plate. Bridge screws, on the other hand, will typically have a longer than normal screw head. Then you have domed head screws, and they usually sit above the surface for easy removal, and they're usually securing some sort of plate. Then you have countersunk or beveled head screws. And these are designed to fit into a conical recess, allowing them to sit flush or even slightly below the surface of a part. A shoulder screw will feature a smooth section, which is the shoulder, slightly below the head. Now, they're made for securing components that require a controlled movement, such as click springs. And that's basically it. Now, there are some variations of shoulder screws, and there are some other specialty screws that you might see, but that's basically it. What separates them from here is their length. Bridge screws typically have longer threads than a screw holding a thin plate. To keep track of what screw goes where, group the screws with the system it belongs to. Also, be mindful of a part or bridge that has multiple screws and look to see if any of them are longer than the others. Sometimes, when there are 2 screws holding a plate, one of them needs to be shorter than the other so that it doesn't interfere with a part on the other side of the movement. So look carefully at the screws as you're taking them out and compare them side by side, and you have to remember where it came from. Now we need to prepare our screwdrivers for our screw slots. As I discussed in lesson 2, this is something that has to be done almost all the time unless you have multiple sets of screwdrivers. I am just going to check every screw type and adjust each screwdriver for the screws in this movement. Here is my screwdriver for the setting lever screw, the setting lever jumper, the ratchet wheel, the crown wheel, the click spring, the barrel bridge, the train bridge, and the balance cop. And we will have to check the pallet bridge screws after we remove the balance. Now with our screwdrivers ready, my last bit of advice is to take a picture. Lots of pictures. Literally, take a picture after each part is removed. Look, this is done by professionals as well when they run into something that they haven't seen before. It's also a good idea to download a text sheet. Now, there are no text sheets that I know of for these movements, but you could just use the one for the ETA 6497 or 98. This video series is made possible by my supporters on Patreon. Now, if you like this type of content, consider supporting the channel. I upload exclusive content only available on Patreon, and there are other perks and benefits as well. The link will be in the description. In the next video, I'm going to go through the disassembly order and inspection process. And because there is so much more to learn, I'll see you in the next video.